Hello everyone, welcome back to my another tutorial. So this will be more practical tutorial, and again, one more time about YOLO and TensorFlow object detection. But actually right now it will be everything different. It will be one of my last tutorials. I think there will be one more after this, but actually there will be only the results. And right now what I would like to talk that how we can create our training data for our training model if we don't want to label everything manually. So actually, if you remember 2 years ago, and if you were watching my tutorials, I made a aimbot tutorial for Counter-Strike Go shooting game, or it's a simulator, doesn't matter actually. I thought that, well, it's a great time to do this again, and maybe I have earned a lot of experience during these years, and I can make it even better actually, and maybe my bot could even play better and better frames per second and so on. And there is one minus for most of you. I actually think that I'm on Linux and you are on Windows probably, but actually the principle how everything will work will be the same, but I won't talk about this in this tutorial. This will be in my next tutorial. So this tutorial will be about how I will create an actually training data, how I'll train to detect these heads and whole targets, for example counter-terrorists, terrorists, and so on. And I thought that, okay, maybe I need to go to the Windows if I would like to play Counter-Strike, but then I started digging and saw that it's very hard to run a TensorRT on Windows, and this is actually why I decided to stay on Linux, because, well, it's much simpler to run TensorRT on Linux than on Windows. Actually, there is some methods, and of course I'll post these links on my text version tutorial, or I'll try not to forget how to run TensorRT on Windows. But actually, it's sad to say, but I'll stay on Linux, and this method doesn't matter. We can use for both Linux and Windows, but when I'll be playing my Counter-Strike Go game and running the aimbot, well, actually my aimbot would run better on Linux than on Windows probably. But I'm not talking about that right now. Let's see how I'll do everything. So actually I wrote an interesting script here. I posted it on tools folder, and there is a detection to XML called. And as you can see, here we write a path of folder where we would like to save our detections. File name, it means the image and XML name, whole image file, boxes, and of course number of classes. And of course, you don't need to get into this code. It will create everything you need. So actually, whole job will be done by collect training data script, and I have two of them. Okay, I'll close both of them and I'll open collect training data. And at first, I would like to say that I will be collecting my training data for this Counter-Strike Go game, and I installed Steam on Linux, and I saw that the easiest way to do that is to use Flatpak, because before I was trying to install it without Flatpak, but there is some issues with drivers when I would like to run CUDA and to Counter-Strike Go, so I couldn't do that. But the easiest way how to run everything was simply install Steam through the Flatpak and just run it. And this is the command how I will run it simply. So actually, let's see my code. There is a very simple while true, and I will be collecting an images, and I use a MSS library, and I of course I'll post all links on my text version tutorial. And this is a simple library which we can use to grab a screen, and it works actually very fast, and I don't think that I will need a multiprocessing. Is actually very fast. I don't know it's improved or something like that, but you can use it on every operating systems, Windows, Linux, and probably on Mac, so it doesn't matter. There is a detect enemy function, and actually this is a copy of my detect image function, but simply I a little bit modified it. And as you can see, here is my detect enemy, and instead of giving it a path of my image, I'm giving it a full my image, which is grabbed by my sctgrab function. And here is everything the same. I use my input size, training classes, and so on. And if, for example, my detector detects more than 0 boxes, I call my create XML file, and my XML files will be copied into XML detections folder with a name of current timestamp. And that's it. And I do a time sleep of 2 seconds, because if there's a high frames per second detection, well, we don't want to get 100 of the same detections, because it's very hard to then manually check all of them. I recommend to use 2 seconds or even more, or 5, it doesn't matter. It depends how fast you would like to detect these results. Or if you are detecting this through a batch of images, I mean, you're running for this for thousands of images, it doesn't matter. You don't need a sleep, you don't need to grab a screen or so on. You simply can run this while loop and give it a batch of these images. So that's it. And here I use a draw enemy, and it's also a draw detection boxes script which was copied. And yeah, I just wanted to have all these scripts on this script, that if I would need to modify them, I don't need to modify these original scripts. And actually, what I also did, if I go to my YOLOv4 and there is all these functions of my detection, I added them to here, create XML files in all of these functions. And if you want to detect a video and you want to create XML files from video, you simply need to uncomment this line, and everything is for the same for detected images and so on. So simply you need to uncomment, for example, here, and you can give batch of images, and this will create XML detections folder, and of course there will be a lot of results of your detections. So that's it. Actually, I think I can run an example how I run a Steam, for example. I simply run a following line from Flatpak, and my Steam just goes on here, and I have a user, PyLessons, and so on. I already have a Counter-Strike Go, as you can see, and I hope it will be possible to run everything, recording Counter-Strike and my bot on the same computer with the same GPUs and so on. And actually, I need to make one more thing, because I'm right now running on TensorFlow, because I was making some tests. I need to change configurations. I will run 460, and instead of TensorFlow, I'll run this following simple TensorFlow model, TensorFlow. And of course, later, not in this tutorial, but in the future tutorial, when I'll have a tested version of my aimbot model, I'll of course upload my whole trained model into our GitHub repository. Of course, I will give all the explanations how you can test it by yourself, but right now it is what it is. And actually I can run a simple game. Play time. What does it mean stop? I'm not playing it right now. Okay, I think it's starting. I need to wait a little bit. Yeah, something wrong. Doesn't matter, everything will start in a moment. And I'll I'll play against harmless bots because I would like to collect a lot of training data of them, and I'll see how everything works. So like that, and this is the coordinates of my screen where I grab a screen. Because I have two monitors, I have to use this kind of function, monitor -1, and this is the top offset of this gap of where it says Counter-Strike Global Offensive OpenGL, because I don't need to get this kind of screen. It doesn't give me any results, so I simply cut this and I grab only this working part of screen actually. And this is the width, height and height of my game. So actually if you're gonna look here, you can see that actually it's the same as here. I use windowed mode and so on, because I don't want to run this on full screen, because it's easier for me to see what's happening here, and that's it. So I can run a deathmatch workshops. I downloaded an AMAP where it will be a little bit easier for me to collect training data, and yeah, I'll run against harmless bots. I'm interested on this and this map, so actually I'm not sure where I'll try first. Maybe I'll try here on this map, and here I'll play around, I don't know, few minutes, and you'll see how much data I'll get from this, and how much time this following script can save for us. So actually, yeah, I'll run Counter-Strike, and I'll run by another gun. I love more this one, and right now I can start a script, and I'll move it to the right screen. It should start my running everything on my GPU. There should be frames per second. Actually, it will be, oh, something wrong here. Sorry, class. There should be training classes. Yeah, so training classes. Okay, let's run this again. So actually you can see the detection results, and I think I'll move it to another screen because you don't need, yeah, something like this. I'll move, you don't need to see the results. What the? Training classes is not defined. Okay. Training classes. Oh, there should be training classes. That was my mistake. And actually, I don't need a screen, or yeah, I don't need a screen. Actually, I'll run this without showing a window, TBG, because it also make it work slower. And actually you can see what is the frames per second of my YOLO model, and as you can see, it got it. I just need to play right now, and I'm just shooting ahead, and I wrote that it will print got it when it captures the object and saves it into my XML detections folder. And in a moment, I'll show you the results, what it got. And of course, then I don't need to manually check everything. I don't need to draw manually all the bounding boxes. I simply need to recheck if they were drawn correctly or not. And then I can simply remove that XML file or simply modify the detection to change the class, label, or bounding box size, or so on. Doesn't matter actually. And there will be, I don't know, right now there will be 60 of these detections, 50 maybe, because As you can see, it gets every 2 seconds because of my delay, and you can't see the true frames per second if it's the text option. Right now I can move up, and in a moment you'll see that my frames per second on YOLOv4 is 30, and it's quite high, but you'll see how it works on the TensorFlow. So actually I can stop it right now, and I can show you the results of these bounding boxes. And if I'll open XML detections, there's a lot of these detections, but how it called? Label img, and there's written how I can run this. I simply macOS Ubuntu. So I go to here, I have my label img downloaded, and here I just run this, and then Python, just like that, open my directory of XML detections, and here we have everything we need. So it detected correctly the terrorist, so I can move it a little bit this side. Okay, so let's check terrorist head. Okay, terrorist head, and simply we need to check them. As you can see, I don't need to label them, but because I already have a model which is working in high accuracy mode, so everything here is quite fine. And there's the head, but let's see, maybe I'll find some. Yeah, counters terrorist head. So here is a mistake, so simply I need to write terrorist head, save. Oh, here is terrorist. It's not. Again, save, and move forward. Move. And that's it, actually. And this is all our training data set generated. And actually, I would like to run this not on this map. I would go to more original maps, AMAP, the Dust, or something like that, and there I would do everything, and that's it, actually. Then as you can see, I have these kind of results of XML detections. I would copy all of them, 76 results, and move to my CSGO images, train, copy here, and then I would run this following function, XML to YOLOv3, because there is already all the configurations I need. And if you need this following training data as I have here, it should be somewhere here in my GitHub, but actually I don't remember. Maybe in part 9. No. Here it is. No, not here. Not here. Actually, I had them server somewhere, this training data. Just anyway, I'll try to find where it is, and I'll maybe here, part images. No. Here it is on the 5th part. So actually I'll try to post a tutorial, my link to these images, which I used as starting point. I trained a model with it, and right now, as you can see, I use them. This is my model to generate a lot of other detections where I check where my model is bad, where it's good, and simply I will train it again on this new data. And of course, in the next tutorial, you'll see my results actually. And for this tutorial, that's it. I just show you how you just can simply save your time and generate a lot of training data where you won't need to label everything, but it's enough for you to check your detection results actually. So that's it. I hope this was a useful tutorial for you, and you can like my video, share it, and comment if you have any questions. And of course, see you in our next part. Thank you all for watching, and goodbye.